if I want to use this network in my command, I have to use wildcard mask instead of subnet mask. So in the wildcard mask, how to find a wildcard mask is to subtract the subnet mask of this network from 255.255.255.255. All right. So since this network is using /30, for example, this 255 minus this 255, is 0. Okay. The second octet 255 minus 255 is 0. Third octet 255 minus 255 is 0. The last octet, which is 4, is 252. So 252 minus 255 is 3. So that's how to calculate the wildcard mask. Okay, let me go back to the system. So okay, good day everybody. It's another beautiful day. We're going to look at an important topic called OSPF. It's a part of dynamic routing protocol. So it's one of the wide dynamic routing protocol, one of the most popular, I'm going to say. Okay, so in my last video I talked about static routing, so which is more time consuming. So dynamic routing is preferable because it's faster and it's also self-healing method. That is, if there's any neighbor that is participating in the routing system, then the neighbor will be removed and it have many other advantages. All right, so it doesn't just create a route, it also monitor the route and then maintain the route. All right, so without wasting time, we are going to create OSPF on each of these routers. Then the routers will advertise their route, that is different destination, to each other. Alright, so they will send hello message to each other to participate in the OSPF neighbor relationship. Then they will advertise each destination they have, in which each router doesn't know about. Alright, so there are some things I need to do in there, but I've already done that earlier, which is configuring loopback interfaces on each of the router to avoid time wasting. So I decided to do that. If you don't know how to configure loopback interface, in my earliest video I have configured that, and then I've also configured the physical IP addresses on each interfaces. All right, so I've done that. So the next thing we're going to do is to go straight to the OSPF configuration without wasting time on the physical IP configuration, loopback IP configuration. All right, so I will assume this router 5 is my network provider's router that will take me to an external network such as the internet. So in case I want to configure default route on this router, we use the IP address on this network provider's address as the next hop. Okay, so the default router will be advertised. That's the default route to reach the internet, will also be advertised to every other routers. Okay, so without wasting time, let me go straight to the CLIs of the routers, then I'll configure OSPF. Alright, so there are two methods. Either you configure the OSPF directly on the interface you want it to be activated on, or you first configure the OSPF from global configuration, then you advertise it on the interfaces using the network command. That is, whenever you want to use the network command, you use the network of the interface you want it to be advertised on. Alright, so let me go straight to the network command method first. And first of all, use the network command method. Then in the other routers, I will use the interface method. Okay, so when using the network command, this wildcard mask is important, so I will show you how to calculate the wildcard mask. But first of all, let me enter the configuration mode first. All right, so enable conft. So to enter OSPF configuration mode, you use the command router OSPF, then followed by the process ID 1. Let me use question mark if it is correct. Okay, so that is correct. I will enter. So I am in OSPF configuration mode now. So I will advertise the network. I want this network, that is this interface that is using this network, to be I want the OSPF to be activated on this interface. So I will use this network. All right. I will also use this network. So each of them are /30. So if I want to use this network in my command, I have to use wildcard mask instead of subnet mask. So in the wildcard mask, how to find a wildcard mask is to subtract the subnet masks of this network from 255.255.255.255. All right. So since this network is using /30, for example, this 255 minus this 255, is 0. Okay, the second octet 255 minus 255 is 0. third octet 255 minus 255 is 0. The last octet, which is 4, is 252. So 252 minus 255 is 3. So that's how to calculate the wildcard mask. Okay, let me go back to the system. So I will say network 192.168. The first network is .0.0, then followed by wildcard mask 0.0.0.3. Okay, I'm sorry, I have not completed it. Area 0, you have to specify the area 0. So we are using area 0 here. You can use area 1, you can use area 2, but one important rule is that the area must be the same in all the router. If you use area 0 here, make sure in the next router you use area 0 also. But the process ID, like when I want to enter the OSPF configuration mode, the process ID, it doesn't matter, it must not match, but the area must match. Okay, so I enter. So I've advertised it on this network, that is this network, so it will be active on this interface now. So let me advertise it on this network. Okay, so this 192.168.3.0. so I will press the up arrow, then change the network session, this .0 to 3. The wildcard mask is still the same, so I will enter. Then there's one more side I need to configure it on. There is one more network, which is the loopback 0 interface. Okay, so I will hit up arrow. The network of this side is the network of the loopback is 1.1.1.1. Let me clear everything so that I'll see it very well. Okay, then the wildcard mask of 255.255.255 is 0.0.0.0. Okay, because 255 minus 255 is 0. The second octet 255 minus 255 is 0. The third octet 255 minus 255 is 0. The fourth octet is 255 minus 255 is still 0. So why is it 255 for this loopback interface? That is because loopback interface uses /32 mask. Okay, so if you are configuring loopback interface, so the section you are supposed to enter subnet mask, you will enter 255.255.255.255. Okay, so area 0. Okay, so I've activated it on every interface I want it to be active. But there's one more important thing you need to do, which is to configure some interface as a passive interface. Okay, what kind of interface is passive interface? The interface that is not connected to another router. It will be participating in the OSPF process because that network will be advertised to other router, but it will not be sending hello message, that is OSPF hello message, and you shouldn't be receiving OSPF. That interface will not be receiving OSPF hello message, so you have to make it a passive interface. Hello message is sent from OSPF neighbors. Okay, so this particular router that is active, that OSPF is activated on now, will be sending hello message to its other neighbors every 10 seconds. Okay, and then every neighbors will also be sending the hello message to it as well at every 10 seconds. But since the loopback interface doesn't have any physical router connected to it to send this hello message, you need to be on passive mode. So the command is passive interface, then loopback 0. So I want to shut the loopback 0 as LO. Okay, so let me go up. I think there's a hyphen between the passive and the interface, so let me try to do that and see. Okay, yeah, it is accepted now. Alright, so I think I'm done here. There's one more command I will later do here, that is to advertise I will configure a default route and advertise it to every other router, but I'm not doing that right now. So I'm done with the configuration here. Let me end and then show IP protocol to view this. Okay, so routing protocol is OSPF1, that is the OSPF process ID I just configured. Alright, so you see the network I the network command I enter, so the different network. Alright, so I'm going to enter the other routers and configure the same method. But in this, to me, I prefer entering the command on an interface because I feel that is more straightforward, that is faster. Okay, so though your own method, you may prefer to use the network method, but when using the interface method, you don't need to calculate the wildcard mask. You just enter all the commands once. So I'll be using the configuration on the interface here. Alright, so let me do that here on this router 2. Let me use the interface configuration method for you here. So enable conft. I will be activating it on this interface F00, F01, then loopback interface. Okay, loopback interface, that is loopback 0 interface. So let me enter interface range mode so that I will do it on multiple interface at once instead of one interface after one another. So I will just enter interface range mode, interface range, then I want to activate it on F0/0, F0/1, okay, 1, then loopback 0. Okay, so any configuration I do now will make effect on all these interfaces at once. So I want to use OSPF. So watch me do it now. How to activate it on interface? Then the command is IP OSPF1. This is the process ID area. Oh my God, area 0. Okay, so that is all the command you have to enter on the interface to activate the OSPF on the interface. So let me hit enter. Okay, I think there's space between the OSPF and the 1. Alright. Okay, as you can see, the command is accepted now. Alright, so this log message display showed that it has formed a neighbor relationship with the first router 1. That is because I have already activated OSPF on it earlier, which we used the network method on that one earlier. So it has already discovered this neighbor and they have already formed a relationship and it has changed to full state. Alright, so after that I also have to make the loopback interface a passive interface. So that is the last thing remaining here. So let me enter the OSPF configuration mode. Before you make an interface, passive interface, you have to enter OSPF configuration mode. Okay, so router, let me exit of this interface, exit, router OSPF1, passive interface, so, dash interface, loopback 0, right? Okay, so that is all on this router. So as you can see, the interface method is very fast and it's more easier to me. Okay, so I'm done with this router. So do right to save, and then I will show IP protocols. Okay, so you know the first one showed network, okay, but this one since it was activated on interface directly, is not showing the network. Okay, suppose show the interfaces it was activated on, but this is packet tracer, so it's not behaving like a real network device. But if it is GNS3 or real physical network device, it will show all the interfaces it was activated on, which is the loopback 0, F00 and F01. Alright, so I'm going to enter the other router, okay, and do the process quickly. Enable conft. Okay, let me see the interfaces, G00 and G001. Okay, interface range G0/0/021, because they are the same, because they are all both gigabits and the numbers are following each other. So let me also put comma and put the loopback 0. Okay, IP OSPF1 area 0, and it's activated like this. Okay, You can see it has discovered another neighbor from the R2. Okay, so let me enter the OSPF configuration mode to make the loopback interface a passive interface. So router OSPF 1 passive interface loopback 0. Okay, do right and okay, let's go here. Then I'll go to this last router enable conf t interface range G0/0. Let me see the interfaces I'll be activating it on. I will activate it on this G00. I will also activate it on this G02. I will activate it so that it will advertise this network, but I will make this G01 a passive interface because it is connected to a PC as a switch and PC instead of router. So this switch and the PC are not participating in this OSPF. So this interface will be made a passive interface. Okay, so let me do it now. Interface range 0 to 2 comma loop 0. Okay, IP OSPF 1 area 0. Okay, right, so we can discover two neighbors now. Is it router OSPF? So the space between the router and the OSPF 1 passive dash interface loop 0. Okay, I also want to make the G001 a passive interface, so repeat the command up arrow. So passive interface is G0/1. Okay, do right and okay, so show IP OS. Let me show IP protocol. Alright, so it has discovered this neighbor. Discover this neighbor and this neighbor. Okay, the neighbor. How does it identify a neighbor? Okay, so the first thing when using OSPF, either you configure the OSPF router ID using a figure of your choice, so that will represent the identity of that router as an OSPF neighbor. Okay, but in this case we did not configure a router ID, so the loopback interface IP addresses will be used as the identity of the router. So that's why you're seeing different neighbors as 2.2.2, 3.3.3, 4.4.4. That is because the loopback interface is what is used as the router ID here. Okay, so let me also show you in case you want to configure the router ID. So enter configuration mode, it's conf t. Then you have to enter the OSPF configuration mode again, like as using the command router OSPF 1 router dash ID. Okay, the command is router ID. Okay, so you can put the figure here. If I put any figure here now, since I'm on router 4, let me say 4.4.4.3.5. So if I put this figure here now, it will override the initial ID of 4.4.4.4 because the configured router ID is a preferred choice. But if there's no configured router ID, then it will use the loopback ID. Okay. So for example, let me go and check the other neighbors now. Check the other routers as neighbor. Okay. The command to view the neighbor is show IP OSPF neighbor. Okay. So I short it show IP OSPF neighbor. I short the neighbor. Alright. So as you can see, the R4 router is not shown as 4.4.4.5. That's because the router ID I configure is 4.4.4.5. Okay, so the router ID configuration is preferred over the loopback interface IP address. But if there's no router IP address configured, then it will use the loopback interface as its ID. Okay, so we are done with the OSPF configuration, but there are a few things we still need to do. So let me show the routes now, the routing table if there is any route LAN. Okay, so from the current router I am now, I'm on router 3. Let me see, show IP route to view the routing table. Okay, as you can see, it learns many routes using OSPF. O stands for the OSPF. So any route that you see that is written 0 in front is learned through the OSPF configuration we just configured. Okay, it learns the route to all the various loopback interfaces and also learns a route to this physical route. Okay, right. Then these are the few routes it learns through the OSPF. Okay, so we activated OSPF. It also learned a route through OSPF. via 192.168.2.1. This 2.1, which is 2. Okay, through this router. Okay, down to another one, 192.168.0 network via 192.168.1.1. Okay, this is this router. Let me through this router. Okay, so let me check something. Show IP OSPF interface. Let me see the interface is distributed on G00, G000. Okay, so I want to view something here. That is the cost. I believe if you study OSPF, you must have had something about the cost. Okay, so the cost is used to calculate the best route to the destination. So, and we learned that by default, the cost is calculated using the reference bandwidth divided by the actual bandwidth of the interface and the network level. Okay, you see this cost is 1. So if you check most of the route now, because they have a gigabit internet and then a fast Ethernet, the speed will be 1 throughout, because the reference bandwidth divided by the actual bandwidth, we see that nothing is written like 0 point in calculating the cost. So if you divide this 100 by this 1000, which is the gigabit fast Ethernet port, then the reference bandwidth, the cost will still be 1, because anything below 1 will still be written 1 in calculating the cost of OSPF. Okay, so since most of these interfaces are gigabit interfaces, if you divide it by the reference bandwidth, it will be, if you divide the reference bandwidth by this 1 gig interface, that is 1000. 100 divided by 1000 is supposed to be 0.01, right? But in the rule of OSPF cost calculation said that anything below 1 is written as 1. So this calculation will not be accurate. It's always advisable that you increase the reference bandwidth so that the calculation will be accurate. The reference bandwidth should always be higher than the physical bandwidth, okay? So that if you calculate it, if you divide the reference bandwidth by the physical bandwidth, the result will not be below 1. It will not be 0 point anymore. Okay, so let me look at the command to do that. This is actually what I'm looking for that brought me to this section. That is where you see the cost. Where do I see the cost just now? Sorry, give me a few minutes. Cost is 1. So this cost is not supposed to be 1 for gigabit interface. It's because the reference bandwidth is on the default one of 100. Okay, so we need to correct that. Okay, so you have to, if you're changing the reference bandwidth from one router, you have to change it everywhere. Okay, all right. So continue. Auto cost that. I think the command is from the OSPF configuration mode. Let me check that. Router OSPF 1. Sorry, router OSPF 1. Auto. Let me just start to see. Okay. Oh, so the mistake I was making earlier is that I was carrying the reference bandwidth configuration from the global configuration mode. So you have to carry it out from the router's configuration mode. So the command is auto cost. Then let me put question mark to see next. Reference bandwidth followed by the reference bandwidth. Let me just start to complete. Okay, so as I advised, the reference bandwidth should be higher than the highest interface speed on your network. So we have 1 gigabit interfaces on all the routers here. So let's put it on 10 gigabit, okay? So, and it is, 10 gigabit, and it is measured in megabit per second. So 10 gigabit is equals to 10,000 megabit, okay? 10,000 followed by 3 other 0, that's 40. Okay, please ensure reference bandwidth is consistent across all net routers. Okay, so just as I said earlier, it must be the same. If you do it here, you have to do it on other routers. Okay, so let me go to these other routers also. Enable. Oh my god, I'll make a mistake here. Okay, so what I want to, since that one is still coming up, if you don't allow me to type anything after some time, so I will use this time to check the OSPF costs on this router again. Initially the cost was 1, to every network was 1. So let me end here. Show IP OSPF interface G0/0 slash 0. Okay, you see the cost is now 10 instead of 1. Okay, that's because 10,000 divided by 100 is 10. Okay, all right. So the advantage of this is that it will enable the routers to make the right decision to follow the best path. Okay, the interfaces that have the router that have gigabit interfaces will be chosen over the routes that have fast Ethernet interface or just Ethernet interfaces. But if you do not increase this reference bandwidth, it will not be able to make this decision. Okay, it will treat fast Ethernet port and gigabit Ethernet port as equal cost. Okay, all right. So let me also check now to if I can type in here now. All right. Okay, I can type in here now. Let me enter configuration mode with conft router OSPF 1 auto cost. Sorry, auto. Let me use tab to complete reference tab to complete, then 10,000. Okay. Oh, it remains that last thing I promised, that I will also configure a default route and advertise it to every other network, okay, to every other router. For now, there's no any default route in the routing table. Let me prove that with the show IP route. Show IP route. You can see so many routes, but there's no any default route here. So when I configure the default route on this router, then and then I also use a command to advertise it to every other routers, then they will learn a default route also. Okay, so first let me configure a default route. I hope you know how to do that. Let me exit out of here, conft and IP route to destination 0.0.0.0. Then the subnet mask of default route is 0.0.0.0. Then I want to use this router, this network provider routers at my gateway. So I will use the net hub as 204.0.0. What's the IP address there? That's 2.2. Okay, the 2. Do right. Let me show my routing table here. Okay, I'm in configuration mode, so do show IP route. Okay, you can see my default route here. All right, let me also verify something from here. Ping, since there's OSPF neighbor relationship now, it must have learned a route to this PC. So let me ping this PC from this R1 192.168.192.168. I think it's .4, but let me be sure. .4.3. Okay. .4.3. As you can see, you can reach it now. Okay, so the last command to advertise this default route is what we're looking to next. But before I do that, let me prove to you that other routers doesn't have a default route yet. Show IP route. Okay, as you can see, there's nothing like default route yet. Okay, so the command is let me enter configuration mode. Okay, the command is default information originate to advertise the default route to every other OSPF router in the network. Okay, so let me prove that by showing the routing table of the router again, the other routers. Okay, as you can see, it now have a default route. That's because it learned it from the router with the default route, and it has advertised the default route to every other router. Okay, so I can ping any of this loopback interface from any of the router. 1.1.1.1. Okay, 2.2.2, 3.3.3, 3.3.3, 4.4. Okay, that's all for today. So if you like this video, don't forget to like, share, and subscribe to my channel. Thanks for watching.